Greetings and welcome to another Dev Bootstrap screencast. In this screencast, I'm going to run through how to build a bot that will try to get a transaction by looking at certain transactions in the transaction pool. And as soon as it sees a transaction that it's monitoring, it will then try to execute a secondary transaction. Now, this example was inspired from basically a lottery example from an article I read on the web. So let's take a look at the repository. So, as always, Dev Bootstrap under GitHub has the full source code for this bot and for this example. We're going to be using Geth, and so there's instructions here on how to set up and install Geth, how to add scripts to Geth so that they make your sort of working life a little bit easier, so you can do things like check balances and unlock accounts and stuff like that. It's things that don't really come out of the box with Geth, but they help you if you're using Ganache. But we're going to use Geth. So let's take a look at this now. And the other thing is this was inspired really from this article here. So I read this a few months ago, and what I thought I'd do when I read this article was I would simulate this approach here, which is basically the sort of example that this author gives about this case of having bots that are performing transactions on the blockchain and watching the blockchain for specific transactions. So here, the example is there's the bots. There's Bob's Lottery, and what we're going to do is we're going to the Bob has deployed his lottery contract or made a change to the state of his lottery contract, and then our bot will try to win the prize. So that's the scenario. That's what we're going to be looking at. So we'll start off with the contract. So the lottery contract, really, I decided to make this into a counter contract. So it's basically something that is a very simple smart contract that basically just has a counter. So the counter value is here, and then there's also a counter limit. And what I do is essentially, to play the game is you need to increment the counter. But there's one caveat, which is that you cannot increment the counter beyond the counter limit. And only the contract owner can increment the counter limit. So this means that since we deploy the bot with the contract with the counter and the counter limit both set to 0, it means that no one can play this game. No one can call increment, even the owner, until the owner themselves call release next increment. And so when they release the next increment, that will increment the counter limit by 1. And that means that the increment function can then be called. But until this function here is called by the owner, because only the owner can call this function, the increment function will always revert due to this statement here. Okay, so I hope that's clear. And this is the contract that we're going to use in our example bot today. So onto the bot. Now, so what the bot does is it has an initializer, which basically asks a bunch of questions. I'm using the Inquirer package, if you're interested, which is pretty neat. It just allows you to sort of structure a bunch of questions in this format, in an object format. And so I ask, what is the contract address that you're watching? What is the owner that you're interested to watch to execute that certain function? What is the function signature? And you can add a bunch of questions here. And then I pass the answers onto what I call a watcher. And the watcher is over here. The watcher basically takes those answers, which I call filters here, and I subscribe to pending transactions directly to our Geth node, and then every transaction that comes in, I check, do the parameters match? So does the hash match? Does the from match? The to match? The input match? And if it does, then we go ahead and pass that onto this sniper, and the sniper basically tries many times to execute the transaction until, well, hopefully it succeeds, right? And so the idea is that it's going to try and multiple times over and over and over again to call this increment function, right? The function that essentially is claiming the prize, claiming the lottery, right? As I mentioned, in the repo, we have this README. The README contains instructions on how to start Geth, and if you haven't installed Geth, there is another section under Geth dev. There's another README here to how to install that. There's also how to attach to Geth and how to add helper scripts to Geth as well. So what I'm going to do is head over to my console, and we're going to start up some of these things based on the README. So up here in the top left, I'm going to start a Geth node. So Geth, and then I set the data directory to the Geth-test directory and set the network ID to 15. You can set the data directory to whatever you like or keep it as the default for your system, but I'm keeping it here so I've got access to it and I can check it out if I want to. Okay, cool. So this is actually Geth running. Now I'm going to attach a node. So down here, bottom left here, I'm going to, let me just expand this a bit here, attach a sort of a Geth console to this node. And the way you do this is you run Geth attach, and then I'm pointing at the directory where I'm running, where I told Geth to sort of store its data and the blockchain and the key store and everything. And it also creates an IPC file, and that's how we connect to that. So that's where we connect to. And we can run things like listing accounts, like so. So we can see the accounts that are on the node. We can also use TxPool, inspect, and we can see what's in the transaction pool. And as you can see, it's currently empty. All right. So the next thing I'm going to do is I'm going to, up here, or let's have a look here. I'm going to connect it here in the middle to Truffle console. This is just so that I can interact with the contract to just check who won, right? So how do I do that? Well, let's have a look at the network for a start. The contract, I've already deployed it actually. So if you're not sure how to deploy, it's migrate -- reset, and it will just deploy the simple counter contract. But I've already done that. So as you know, to get a hold of an instance of that, I just call await and simple counter deployed, and that will give me an instance of the counter, and I can check. So I've got a method on the contract called get counter. So we can see what the current value of the counter is, and it's currently 3. That's because I've been playing around with it a little bit for recording. So given that the counter is 3, we can now check the winners mapping to see who won that prize. Who won counter 3, let's say, right? Who won prize 3? And it was this account here. If we check the accounts, you can see that it's this account down here. So that account is one of the accounts that's used by the bot. So when I was running this off camera, yep, the bot claimed prize number 3. Now, I can just clear this out here. If we look at winners 4, you see it's unclaimed, right? So when you see a 00 address like this, it means the prize has been unclaimed, okay? Now, what we want to do, of course, is we want to simulate the scenario of Bob, our lottery owner, basically releasing or deploying a new lottery. So in our case, the way to do that is to call the release next increment function of the smart contract, right, as you may remember. And up here, I've got a simulator that does that. So there's a little script here in the simulator directory called lottery, and that will call the function release next increment and allow me to increment. So let's just show that. If I call increment here, I get, the account's locked. That's great, that's fine. what I need to do, of course, is import the unlocked account script. So this is something I should have done earlier. And then I need to call unlock accounts. This is just Geth, right? It's because we're using Geth. If you're using something like Ganache, you'll probably not have to do this. But the thing is, Ganache doesn't have a transaction pool, so that's why we're using Geth. So the account was locked. Now let's try to increment again. Now, as you can see, it submitted the transaction. And let's have a look at the transaction pool. Okay, so it's there. Now it's not mining, so I'm going to mine by using miner.start. Okay. And it's committed the mining work there. And we don't really get much. Oh, here we are. Yeah, it reverted. Yeah. The current counter has already been claimed. Okay. That's because, by calling increment, it hit the revert in the contract. Let me just show you again. Increment here, current counter has already been claimed. So it hit that revert because we haven't, the owner, Bob, the contract owner, has not released the next counter. So let me run this over here. I'm not running the bot yet. This is just the simulator. This is simulating Bob releasing the next increment. Okay, so that's just run. If we look at that, it's submitted. The miner's mined it. So what should happen now is if we look at winners 4, it's still empty, right? Because we haven't claimed the prize. If I increment it, so I call increment, and that's submitted another transaction, and wait for that to be mined. As you can see, now winner 4, before winner 4 was unclaimed, now winner 4 is this account here. And this account is actually the first account. If we look at the accounts here, it's the first account, which is actually the contract owner. Okay, so that was just to show you that we cannot call increment until we run the release next increment function. Okay, until we call that function, and that's how we do that up here in this window here. Okay, so what I'm going to do actually is I'm going to just close this out a little bit here because we're going to use that later for something else. But what I'm going to do is I'm going to actually now start the bot. Okay, so sort of moment of truth, if you like. So let's clear that out, clear the screens a little bit here. I'm going to start the bot. Okay, so the bot has started. Actually, it's asking first of all, which contracts to watch. So I'm going to show you how to get that first. So with networks in Truffle console, you can see the deployed address of the simple counter. So we're going to just drop that in. That's the first thing. The address of the owner is just the first accounts, like that, and we just grab that address like so. Okay, and then the function signature of the hash to watch, which is currently set to this, is actually from here. So I have a plugin in Visual Studio Code which gives me the function signature, and the method we want to watch is the release next increment. That's the function that we want to watch, for our bot to watch. So you click on function sig, it gives us the function sig here. And by the way, notice that it starts with the 0x, right? So make sure to remember that. Make sure that these parameters are exactly as the addresses and signatures that you want to watch. Okay. Up here I've got a simulator. This is basically a little script that I've written that basically simulates or basically calls the method release next increment. So it's like Bob saying, hey, I've got a new lottery to run, let's go for it. Now before I run that, I'm going to stop the miner. So I'm going to call miner.stop over here. This is just so that we can inspect the transaction pool. So if we have a look at the transaction pool, you see it's empty. If I run this now, we want to keep an eye on the bot down here to see that it will pick that up. So click that there. Bob submitted the new lottery. Down here in the bot, let me just expand this out a bit. You can see that it detected a new transaction. It also output how many count of the transaction pool. Then it says, oh, I found a matching transaction based on your filters. It's got it lists the accounts that are going to be used to try and win the lottery. Notice it's all the accounts except the owner account, right? So just to show you that here, if I type accounts, you can see that it's all the last set of accounts. It's just not including the owner. And it's now submitted a transaction, and of course the transaction pool is now 2. So if we head over here, we can look at the transaction pool and expand that out. You can see the 2 transactions here. So this is the owner. This is the owner's transaction, and the owner is calling the function to increment or release the next increment. And this is the transaction coming from our bot, which seems to be coming from account B3, which is the second account in the list. And they're just sitting there in the transaction pool at the moment in Geth because we haven't mined them. So if I call miner.start, it starts the mining process. Over here, we should see this complete now once it's mined. And up here as well, we should see both of these complete. And we do. So in the simulator, that is the Bob releasing the lottery, and that went into block 13745. Down here, this is the bot winning the lottery, and that also went into block 13745. And so that is it. If we look at the Mem Pool again, we see that it's now been emptied out. Now, I do have another little thing to add, just to sort of make this a little bit more interesting, if you like. I've got another simulator, which I'm going to run over here. This simulator is like a traffic simulator. So it's just going to be sending small amounts of Gwei between 2 accounts. And it's going to constantly do that over and over and again. So it's A sending B 10 Gwei and B sending A 10 Gwei. And as you can see, the bot picks up those transactions, but it's not actually submitting new transactions. It's just detecting these ones, just to show you that it's always watching, but it's only going to actually act when it sees a transaction that it's looking for, which of course is our lottery contract being updated with a new release. So let's simulate that again. So I'm going to just run the simulator. And what we should see down here, if I just output that, you see there that the bot ran, and it ran many times to try and win the lottery. And it stopped after about 9 attempts. And then in a second, when this is mined, we should see the success here as well. And there it is. So the bot basically mined, the bot is down here. So the bot won the lottery in block 13756. And Bob basically released the lottery, and that got mined in also in 13756 in that block. So the transaction pool should be empty, apart from these simulated transactions, but it's mining, so it's going to constantly mine those. So if we stop the simulator and quieten things down a bit, basically I left that to the end, basically because it's easier to have a look at it before without too much traffic going through. But that was just an idea to just sort of show you a little bit of traffic going through the Geth node there. So please take a look at the repository. The source code is in here. The README has everything that you need in there, I think, to get started. I can just delete these. So the README is here. We can open the preview. So yeah, feel free to check this out, and let me know if you have any comments in the comments section. I'll link to all the repositories. I'll link to the article that inspired this, and to anything else that I can think of, like how to install Geth and so on. So I hope you enjoyed this. I hope you find it useful, It's just an experiment. It's not ready for production. It's not really intended for production. It's just to show you how you can monitor the transaction pool in Geth and look for specific transactions. So thank you very much, everyone. Take care. Please hit the like button. Please share. Please subscribe. And I'll see you in the next video. Bye-bye.